Okay, I know that title sounded super dramatic, and you might be thinking, that's a great title and all, but such an exaggeration. But I would disagree. First of all, what would you want me to do? Use a boring title for my videos? And second of all, this is no exaggeration. You see, synapses are essential for creating thoughts, emotions, personality, memories, and everything you take for granted daily. Of course, so are action potentials and neurotransmitters, but hey, I wanted to use a cool and interesting title, can you blame me? So, what are synapses? Do we know everything there is to know about them? And if we don't, what is left to discover? These are the questions we will be tackling in this video. Hopefully, by the end, you will have an answer to all of them, and we'll see how this video connects with the previous one that was all about action potentials, giving you a much clearer understanding of how the brain works at a very fundamental level. Firstly, let me address the title of the video one last time, because the void I mentioned isn't actually the synapse. The space between the two neurons is called the synaptic cleft, and is where the neurotransmitters are passed on from one neuron to the other. Now, if you watched the previous video, you'll know how action potentials are passed along the neuron to be transmitted to other nerve cells. Well, when the action potential reaches the end of the neuron, more specifically, the end of the axon of the neuron, this electrical signal is transformed into a chemical signal through neurotransmitters. We will talk about these in a later video, but the essential point here is that these neurotransmitters are stored at the neuron terminal, ready to be released once the action potential reaches it. The neuron which releases the synapse is called the presynaptic neuron. Once the action potential reaches the axon terminal of the presynaptic neuron, an influx of calcium in the terminal causes the neurotransmitters to be released in small vesicles to the neuron receiving this information, which we call the postsynaptic neuron. This process could be thought of as almost like a warehouse. Trucks bring items into the warehouse to be shipped off, and workers store these items in preparation for when someone places an order for them. The presynaptic neuron stores these neurotransmitters ahead of time in preparation for when an action potential requires them. Once an order has been placed, the warehouse workers ensure these items are packaged correctly and dispatched to the right location. Similarly, when an action potential reaches the presynaptic neuron terminal, the neurotransmitters are packaged into small vesicles, which will carry them to the axon's membrane and into the synaptic cleft. Now, the neurotransmitters are drifting in the synaptic cleft, working their way into the postsynaptic neuron. When they reach the membrane of the neuron, strategically placed postsynaptic receptors are there to receive them. These receptors are proteins that have a specific shape and are there to make sure that only particular neurotransmitters are capable of activating the postsynaptic neuron. Once enough neurotransmitters have bound with their respective receptors, an action potential is generated in the postsynaptic neuron, and the process repeats itself again, potentially even giving rise to a brain-wide response. Now, you might be wondering what happens to the neurotransmitters after all is said and done. Some of them simply diffuse away as they were made with the intent of quickly degrading after their single use, while others are cleared from the synaptic cleft by a specific cell type called glial cells. Finally, other neurotransmitters are returned to the presynaptic neuron for repackaging and reusing, meaning the process that a specific neurotransmitter undergoes heavily depends on its size and type. So there you have it. I hope you can see how synapses are something like a conversation between neurons, allowing them to share information with each other. While we have a good understanding of the synaptic mechanism, one question still left to answer relates to their plasticity. When I say plasticity, I mean the capacity that neurons have to learn. For example, if a specific synapse isn't being used anymore, either because the behavior it was used for stopped being important, or the memory trace it supported isn't relevant anymore, they will simply terminate that synapse and create a new, more useful connection with another neuron. To illustrate this, let's say, for example, that you are quitting smoking. Let's say that, when you smoke, two neurons in your brain are synapsing, helping this behavior to exist. Now, when you stop smoking, you replace this with another, more healthy habit, like practicing mindfulness. In this example, every time you get a craving to smoke, but you instead pay attention to your breathing, these two neurons which previously used to synapse whilst you were smoking, now aren't synapsing as much, because the behavior isn't practiced as much. Meanwhile, the presynaptic neuron of this pair is now synapsing with another neuron, in a connection that signifies this mindfulness practice. Over time, the first connection will die out and stop existing, while the new synapse will be thriving. This is what is meant by plasticity. It is nothing more than the capacity the brain has for learning new habits and skills, while letting old, unused ones die out. This is especially well represented by the expression, if you don't use it, you lose it. This sounds quite simple, but I want to leave you with the awareness that this isn't the full scope of what learning is. In the introduction of this video, I promised to tell you what is still left to know about synapses. Well, firstly, we aren't yet fully aware of how this process of plasticity happens, as we don't know how neurons are capable of seemingly choosing which synapses to maintain, which to eliminate, and what other neurons to synapse with. Because this is such a fundamental process in the lives of literally every living being, there are a lot of different hypotheses regarding the processes that lead to learning. Going through all of these would be a video or even two of their own though, so you can expect another video discussing these different hypotheses in the future. But for now, all I want you to take away from this is that there is still a lot to find out about synapses as they pertain to brain plasticity and learning in general. So there you have it. The synapse is super fundamental, and we are still getting closer and closer to fully understanding how it works. Hopefully, the day we do isn't too far away. But for now, leave a like and consider subscribing if you enjoyed the video. If you haven't, go check out my previous one about the action potential, which links directly with this one. And stay tuned for the next one, which will be about neurotransmitters, and we'll finish this trilogy of videos. Thank you so much for watching, and I'll see you on the next one.